Imagine this: you're standing under a sky, dotted with stars, and one of them stands out more than the others. It's the mighty Betelgeuse, a massive, fiery red star in the constellation Orion that has fascinated astronomers and stargazers for centuries. But then, something truly remarkable happens. In late 2019, this brilliant star, which has been a constant fixture in our sky for millennia, suddenly begins to fade. Not a gradual dimming, but a rapid and dramatic drop in brightness that left astronomers scratching their heads. This isn't just another fluctuation in the life of an aging star, no, this is something bigger. This mysterious dimming of Betelgeuse became a worldwide sensation, sending astronomers into a frenzy of research. Headlines from around the globe proclaimed it a cosmic anomaly, and naturally, the big question arose: what on Earth, or rather, in space, is happening with Betelgeuse? Is this just another quirk in the star's life cycle, or is this the beginning of something far more explosive? Could we be witnessing the precursor to a supernova, the cataclysmic event that would forever change this star, and perhaps even our view of the cosmos? The Great Dimming, a cosmic shockwave. When Betelgeuse's dimming first captured astronomers' attention, it wasn't just an offhand event, it became a phenomenon. By February 2020, the once brightly glowing star had reached a brightness level so low it sent shockwaves through the astronomy community. The event became so significant, it earned its own name, the Great Dimming. Now, when a star gets its own nickname, you know it's making some serious waves. Stars, especially the massive ones like Betelgeuse, do experience fluctuations in brightness. After all, they're constantly undergoing cycles as they burn through their fuel. But this was no ordinary dimming. It was as if Betelgeuse had suddenly gone dark, pulling a disappearing act so sudden and dramatic that it captivated the world's attention. Now, naturally, you might think, this is just another aging star doing its thing, right? Stars do dim, fade, and brighten over time as they burn through their fuel and progress toward their inevitable death. But the scale of Betelgeuse's dimming was unlike anything astronomers had ever seen before. It wasn't like the usual cyclical dimming we expect from red supergiants, it was an extreme shift. And that raised a lot of questions. Could this sudden dimming signal a cataclysmic event? Could Betelgeuse, this gigantic star, be preparing to collapse under its own weight and burst into a supernova? Supernova on the horizon. To understand the gravity of the situation, let's take a closer look at Betelgeuse. It's a red supergiant, which means it's already at the tail end of its life cycle. These massive stars burn through their nuclear fuel at a rapid rate, and once they exhaust their fuel, they no longer have the power to sustain themselves. The core contracts, while the outer layers expand. In the final stages of their existence, red supergiants eventually explode in a supernova, a spectacular explosion that lights up the entire sky. Betelgeuse has been a star of intense interest for years, precisely because it's nearing this explosive finale. The big question, though, is when. Supernovae don't happen on a schedule. In fact, predicting when a star will go supernova is one of the most difficult challenges in modern astronomy. It could be millions of years before Betelgeuse finally blows up, or it could happen tomorrow. The truth is, we don't know. And that's why the Great Dimming event had astronomers on edge. Could it be that we were witnessing the early stages of this massive star preparing for its final, explosive act? The dimming, combined with other signs of unusual behavior, sparked a flurry of research, with scientists pointing their most powerful telescopes, like the Atacama Large Millimeter/Submillimeter Array, ALMA, toward the star to try and crack the mystery. The curious case of Betelgeuse's behavior. What they discovered was more perplexing than anyone anticipated. First of all, Betelgeuse's dimming wasn't just caused by a temporary cloud of dust or gas. Something deeper was happening beneath the surface. ALMA's observations showed that Betelgeuse's surface was undergoing extreme changes, but what could have caused such a dramatic decrease in brightness? Could this dimming event simply be a part of Betelgeuse's aging process, a natural phase for a star about to burn out? Or could something more catastrophic be taking place, like the early signs of a supernova? As scientists delved deeper into their analysis, they also began to notice another peculiar thing: Betelgeuse was spinning faster than expected. The mystery of rapid rotation. Typically, when a red supergiant like Betelgeuse expands, its rotation should slow down. It's a matter of physics. As the star expands, the principle of angular momentum dictates that its rotation should decrease, much like an ice skater who spins faster when pulling their arms in and slower when extending them outward. But Betelgeuse wasn't following that rule. Instead, it was spinning at a rate of about 5 kilometers per second, which is 50 times faster than other stars of its kind. This anomaly raised even more questions. Could this rapid rotation be an early sign that Betelgeuse is heading toward a supernova? Could it indicate something is brewing inside the star, something that could lead to an explosive end? The illusion of rotation. What's really going on? As scientists continued to study Betelgeuse, they uncovered an even more fascinating explanation for its rapid rotation. Instead of actually spinning, it turned out that Betelgeuse's surface was bubbling, a process called convective flow. Picture a pot of water on the stove, boiling away. From a distance, you might think the water is spinning. But in reality, the boiling water is simply undergoing convection, where hot water rises and cooler water sinks, creating a swirling motion. The same thing was happening on Betelgeuse's surface. These convective currents create giant bubbles on the star's surface. Some parts of the surface move toward Earth, appearing blue-shifted, while others move away, appearing red-shifted, giving the illusion of a rapidly rotating star. The movement of these bubbles, rather than actual rotation, caused the illusion that Betelgeuse was spinning far faster than it should be. What does this all mean for Betelgeuse's future? Now that we understand Betelgeuse's rotation is merely an illusion, what does this mean for the future of this magnificent star? The dimming, the rapid spinning, and the bubbling surface are all indicators that Betelgeuse is nearing the end of its life cycle. As a red supergiant, it's burning through the last of its nuclear fuel, causing the outer layers of the star to become increasingly unstable. The great dimming might be the result of Betelgeuse expelling large amounts of gas, which formed a temporary dust cloud around the star, blocking out some of its light. While this dramatic dimming isn't necessarily a sign that Betelgeuse is about to explode, it's still a fascinating glimpse into the final stages of a star's life. Red supergiants like Betelgeuse are known to undergo unpredictable brightness fluctuations, sometimes dimming and brightening at unexpected intervals. The great dimming could simply be part of this natural cycle. However, the possibility of a supernova remains very real. Betelgeuse will eventually go supernova, but when is still anyone's guess. It could happen in a few thousand years, or it could happen much sooner. The unpredictability of this process makes Betelgeuse a cosmic mystery that keeps astronomers on their toes. The cosmic volcano, a lesson in uncertainty. To better understand Betelgeuse's behavior, let's compare it to something a bit more familiar: volcanoes. Scientists closely monitor volcanic activity, measuring things like gas emissions, seismic shifts, and changes in the landscape, all in an effort to predict an eruption. But even with all this data, volcanic eruptions are still unpredictable. Similarly, astronomers study Betelgeuse, monitoring its brightness, rotation, and other behaviors, but they can't pinpoint exactly when the supernova will happen. It's a cosmic waiting game. A supernova for the ages. If Betelgeuse were to go supernova, it would be one of the most spectacular events ever observed in modern astronomy. The explosion would be so bright, it could even be visible during the day for weeks, if not months. The light would be blinding, and the explosion would leave an unmistakable mark on the night sky. But